Okay, we're going to take a look at factoring out the GCF, the greatest common factor. That's a term you should know a little bit about. Let's take a moment and just think about this for a minute. Greatest, they mean the largest. Common is commonly used in math. Common means the same. And factor, what does factor mean? Well, factor is basically something like a number or a variable that multiplies everything else in the same term. Okay, let's take a look at, so factor basically implies multiplication. Let's take a look at an example of a factor, just to see exactly what this means. When we look at this problem right here, 5 times 2, we know 5 times 2 is equal to 10. What we can say is that both the 5 and the 2 are factors. And if these are factors, what do we call the 10 in this problem? Hopefully you thought of the word product. So a factor, GCF, factor, is like the 5 or the 2. It basically implies that it's something that is multiplied by everything else in that same expression. It multiplies everything else in the expression. Let's take a look now at the definition of factoring. There are going to be a number of different factoring techniques or patterns that we're going to study. But what is factoring? We want to make sure that we know that. Factoring is basically writing an expression as a product. Let's write that down. Writing an expression as a product. What you want to do right here is you want to keep in mind that this is what factoring is defined to be. Let's take a look at some examples of factoring completely. These are kinds of problems that you have probably done before. This right here, I think you're going to find very, very interesting. Suppose you need to factor the number 14 completely. Well, if you want to factor it completely, basically you want to write it as a product. You probably have seen factor trees before. We can break down 14 into 2 times 7. And because these are both prime numbers, we can say that 14 factored completely is 2 times 7. I want you to try number 2 on your own. So pause it, give it a try, then we'll go through that. Okay, let's take a look at this next one right here, 18. To factor 18, we want to go ahead and figure out factors of 18, numbers that 18 is divisible by. And we definitely know that 18 is 2 times 9, so I'm going to write that as 2 times 9. 2 is prime, so we stop with the 2. The 9 we can go ahead and break down into 3 times 3. And so 18 we can basically write as 2 times 3 times 3. Now, because we have a pair of 3's, we could write that as 3 squared if we like, if we want to. We could also leave it as 2 times 3 times 3. Now, these are old types of problems that you're used to. In algebra, however, we're going to take a look at something that I think is far more interesting. How do you factor something like x squared minus 81? What does this even mean? Well, hopefully from your background in algebra, you have realized that if you have a polynomial, and you know what a polynomial is, you can look that up too if you forgot. With a polynomial, what number is x? Well, hopefully you said any number. I use that symbol for number. X is any number you want it to be. It turns out, and we're going to go through this, not in this lesson, but in the following one, that x squared minus 81 could be written as x plus 9 times x minus 9. So just like 14 broke down into 2 and 7, and 2 times 7 gives us the 14 back, this multiplied by that is going to give us x squared minus 81 back. Now, here's something that I think is even more fascinating. Because x can be any number, what you can do is you can set x to be whatever you want, and I'm going to make x into, say, the number 10 to make it not too small but not too big. And let's plug in the number 10. Well, if we plug in the number 10 right here, if we replace the x with 10, we're going to get 10 squared minus 81, right? Well, 10 squared is 100. What's 100 minus 81? That gives us a total of 19, right? But if x is 10, we know that these x's here need to be 10 as well. So let's plug in 10 here. What's 10 plus 9? That gives us 19. What's 10 minus 9? That gives us 1. And whatever number you choose for x, when you substitute it in here and also in here and here, it will always work. Isn't that neat? Now, not only is factoring neat and it gives you some interesting things to think about, factoring is very, very important in math. Why do we study factoring? Well, there are basically going to be quadratic equations you can solve with factoring. You'll be able to simplify rational expressions. You'll be able to complete the square. You're going to use this in calculus and other courses, just to name a few reasons. And so this factoring right here is going to be used often. And if you learn it well here, then later when you see it used, it's going to be a whole lot easier. Now, it turns out that there are a lot of ways to teach factoring. I like to teach factoring by teaching the 6 main patterns here. And that's what we're going to focus on in these lessons. You can think of these 1, 2, 3, 4, 5, 6 main patterns. And let me read them through. Factoring out the GCF, the greatest common factor. Factoring the difference of 2 squares. Factoring perfect square trinomials, we're abbreviating. Factoring by grouping. Factoring trinomials with a leading coefficient equal to 1, and these are quadratic trinomials. Factoring trinomials with the leading coefficient not equal to 1. These are also quadratic. Think of these 6 main patterns right here as basically 6 different flavors of ice cream. You want to be able to make sure that you enjoy all of them for what they are worth. Okay, let's go ahead and now take a close look at the main thing, which is factoring out the GCF. One thing that we can say is this, that the first pattern, factoring out the GCF, is basically the reverse of the distributive property. Let's take a look at the distributive property. Let's take a moment and just review this. If we had to distribute right here, we know that we're going to end up getting 2x plus, say, 6. So 2x plus 6 there. However, if we reverse this, so I'm going to take the 2x plus 6, write it first. And then I'm going to take this entire expression here, 2 times the quantity x plus 3. When we reverse, switch the left side and the right side, this right here is basically factoring out the GCF right there. So this is factoring out the GCF process right there. Now let's take a look at this for just a moment. When we look at this factoring out the GCF, our answer, because this is what we're going to need to be able to come up with, hopefully you realize one thing. When you look at 2 times x, you can see that this expression is made up of a 2 multiplied by an x, isn't it? Now, what number is x? Hopefully you said any number. What about 6? Well, we know 6 is 2 times 3. What do these 2 red groups have in common? What is the same in both? Well, they both have a 2, don't they? And that 2 is what comes out here in front. And so when we factor out the GCF is going to be out in front of parentheses. Now, once we eliminate that 2, everything that's left over, like the x and the 3, comes straight down along with the sign in the middle. So it'll be x plus 3, and those are basically the leftovers. So when we factor out our GCF, our answer will look like this, where the GCF is basically the part that's the same, and the leftovers are the part that is different. And we'll abbreviate right there. Okay, now that we've got that set, let's go ahead and take a look at some practice. Here it says factor out the GCF if possible. By the way, something that I want to mention. If you don't feel comfortable with breaking down numbers into factors, what you may want to do is you may want to go back and watch the divisibility rules lesson that I have up on YouTube. Let's go ahead, though, go right into the main thing. Okay, suppose that we want to factor out the GCF here. Here it says if possible, because sometimes there will be no GCF to factor out, except for a 1 or perhaps a -1, which sometimes you may want to factor out, sometimes you may not. There's a lot to learn. But let's keep it simple. Here we have 2x plus 6. Well, to factor 2x plus 6, what do? Well, hopefully, if you remember well, we did that up here. But let's go through the main process. 2x is composed of a 2 multiplied by an x. 6 we can think of as 2 times 3. Now, when we write our answer needs to look like this, with the GCF first. So what is in common, or what's the same with this group and that group? Well, hopefully you realize there's a number 2 in common, and so that number 2 is going to come straight out here in front. That's our GCF. Everything else is going to go inside the parentheses. So let's get rid of the 2 in both of these, and let's see what's left. We're left with an x and a 3. So x in front, 3 in the back. And then the sign in the middle comes straight down, and we're done. That's basically the process. Now, there are many, many ways that teachers can teach you to do this process. I want you to go ahead and try number 2. So pause it, give it a try, then we'll go through it. Do your best. Okay, let's take a look at problem number 2. Hopefully you got an answer of 5 times the quantity x plus 2. So looking at problem number 2, here we have 5x, which means it's 5 times an x. Here we have a 10, and we know that 10 is going to be 5 times 2, or 2 times 5. It doesn't matter which way you write it. Now, what part is the same? As we look, both of these groups here, the front group and the back group, have a 5. And so that 5 is going to come straight out here in front, like that. And that 5 matches up with our GCF up here. Let's get rid of the 5. What's left over? X in front comes straight down. The 2 in the back comes straight down. And the sign in the middle comes straight down. By the way, after a while, you're able to do these problems quickly in your head. And I want you to get to that point where you're able to do just that. Try number 3 on your own, so pause it. Okay, let's go through problem number 3. With problem number 3, hopefully you got an answer of 2 times the quantity 2x minus 7. Let's take a look at that. We can take the number 4, and we can factor that into 2 times 2. Then we have an x. Now we have a 14. We can factor that into 2 times 7. What part is the same? Well, there's a 2 here that matches with that 2. They are the same. What about this 2? That's the same as this 2 also, but we already used this 2, so you can't use it again. So that 2 basically from here and here comes straight out in front as our GCF. Everything else comes straight down, so it'll be 2x minus 7. Okay, let's go ahead and move on and take a look now at a problem that's a little bit different. I want you to try number 4. Okay, let's go through number 4. Hopefully your answer was 6 times the quantity x minus 4. Let's take a look at that one. As we take a look at 6x minus 24, I'm going to go ahead and factor the 6 into 2 times 3. And then the 24. To factor the 24, hopefully you took 24 and you could do it in your head, or you could break it up like using a tree, for instance. And 24 breaks up into 2 times 2 times 2 times 3. And again, that's on my divisibility rules video. So let's write that here. 2, 2, 2, 3. Okay, Next part, what is the same in both the first group and the second group? Well, when we look carefully, both groups have a 2 right there, that's the same. And also there's a 3 that's the same. So both of those are the same. So we're going to take a 2 and a 3 and pull that out in front. And these two numbers do get multiplied. Everything else goes inside the parentheses. So we're going to get an x from the first term, then a minus comes straight down. Then 2 times 2 gives us 4. So this will be 6 times the quantity x minus 4. Okay, ladies and gentlemen, I want you to try number 5 on your own. All right, let's go through problem number 5, see what we got there. Hopefully for your answer, you got a final answer of 4 times the quantity 2x plus 3. Let's take a look at that. So here we have 8, which breaks down into 2 times 2 times 2. Here we have 12. Make a tree for it if you're not sure. That breaks down into 2 times 2 times 3. Next step, what's the same? 2 times 2 is in both. So out in front here, we're going to get 2 times 2, which is going to be 4 in a moment. Everything else comes straight down, so 2x plus 3. Multiply here, 2 times 2, we get 4 times 2x plus 3. That's it. Okay, number 6. I want you to go ahead and try number 6. Okay, let's take a look at number 6. With problem number 6 here, we have the number 7, and then we have an x. 7 is already prime, so that cannot be broken down. This will be 7x. Here we have the number 7 again. I'm going to write that as 7. In fact, what I'm going to do here is just because we have a single number here, I'm going to write this as 7 times 1. Is 7 times 1 the same thing as 7? Of course. Now, let's see what's the same. We have a 7 in both, so 7 comes out in front as the GCF. Once we get rid of the 7, we're left with an x, a minus, and a 1. And that's it. All right, now we've got that done. Let's take a look at a few more challenging examples, then we're done for now. In problem number 7, what we've got is x squared plus 4x. Give it a try. Okay, let's take a look at this. X squared is composed of x times x. 4x is composed of, well, 4 is 2 times 2 and then x. What's the same in both groups? Got to be in both. It'll be an x. Cross it out. Then we're left with x plus a 4, right? 2 times 2 gives us 4. Again, our goal here, after a while, is not to write down anything on top, but to do this in our heads. Let's go ahead and we could do number 8 the same way we did all the rest of the problems, but let's try to do this now in our heads. I want to sort of guide you through. How do we do this in our heads? Well, basically, let's take care of our numerical coefficients first. We have a 6 and a 9. And I want you to think about the GCF. What's the greatest factor of both? What goes into both? The greatest number. Well, hopefully you thought 3. So we can take out a 3 from both of these. Now, what else is in common? Well, as we take a look right here, we have an x squared and an x to the first. X squared we know looks like this. X to the first we know is just a single x, so there's an x in both. So 3x is going to be the entire GCF. Next step, let's go ahead and see what's left over. When we pull out the 3x, that has the effect of basically dividing both of these terms by 3x. And when both of those terms are divided by 3x, we're going to end up getting a 2x plus a 3. Now, if this is something that's challenging for you, you may want to go ahead and write it out this way. Now, something else I want you to realize is this. When we see a variable in both of these with the same sort of situation with an exponent, here we got an exponent of 2 and an exponent of, well, we did write in a 1. Which exponent comes out in front with the GCF? Well, the exponent of 1 comes out in front. And so when you have a variable with exponents like this, and we wrote in the 1 like I said, always take out the smallest exponent. So take out the smallest exponent. What do I mean? Well, 2 and 1, what's smaller? 1 is smaller. So that exponent of 1 goes out here. All right, try number 9. Okay, let's give number 9 a try. That is our last one today. As we take a look right here, we have 5, 35, and 10. What's the greatest number that goes into all of these? Well, because they end in 0 or 5, we know we can pull out a 5 from all of them. Also, we have x to what powers? 4, 3, and 2. What's our smallest exponent? Smallest exponent is 2. So this will be an x squared. So 5x squared is what we have in front for the GCF. Now everything else is going to be the leftovers, and this will end up being x squared minus 7x plus 2. Okay, ladies and gentlemen, good luck with your math. Hopefully this helps with factoring.